Let's discuss LeetCode problem number 147. Basically, insertion sort a linked list. Before we discuss, please share, like, subscribe, and hit the bell button for notifications. Now, back to the problem. Like you are given a linked list like this, like 4, 2, 1, 3, and you are supposed to return the head pointer of this, like pointing to 4, and now you are supposed to return a sorted linked list with the head pointing to 1 after you sort it. So you are not actually copying the nodes, you are just the initial sorted head pointer. You are just rejiggering the pointers rather than actually creating the nodes. So these nodes will actually exist, so you are not creating any extra memory for this. And I call this as begin and middle pattern because those are the two separate cases you need to handle. If the next node is supposed to go at the beginning, that is a special case, or if it goes at the middle or at the end, it's the same case. So it is begin and middle are two separate cases you need to handle. So you start off with a dummy node because of you need a dummy node to act as a start. So this is how it will be: dummy to 1, 2, 3 to 4, and actually at the end you return dummy.next. So because it is created on stack, you don't need to worry about releasing the dummy node's memory. It will automatically go out of scope and the memory is reclaimed once this function call is done. So now you start off. So there are 3 pointers now: previous, head, and next. So these are the 3 things you need. Head is the node you are trying to work right now, and you want to basically find the position of the head by actually making that you will insert the head after the previous and then move the head to the next. So that's why you need previous, head, and the next pointers. So while head pointer is not equals to null, now you get the next, you set the next pointer to head dot next, and now this is where the two things comes. You want to find out if you are going to insert at the beginning or you are going to insert at the middle or end. So say for example you already dealt with 4. Now you want to find out like previous dot value 4 is greater than or equals to heads dot value, which is 2. Now you know 2 has to be inserted because 4 is greater than or equals to. So you use that dummy node we created, set it to previous, and then now I don't think it will go into this scenario because you already covered that the previous position. So now when we come here, this is where you need to have. So for example, I'm taking this example how this works. You are at 1, 2, 4 and you are inserting the 3. Now previous becomes 2, and then previous dot next is 4 and head equals to 3 because previous is 2, so you are inserting 3 between 2 and 4. It is a standard linked list insertion logic. So now you want to get heads dot next equals to pre dot next. So you want to make sure the next node after 3, which is head is 3, is 4, which is the previous dot next pointer. And so the previous dot next, which is 2, equals head. So now 2 points to 3, and then you move the head to the next, and then you initialize the next here. So that's how the whole list gets sorted. So now coming back to this situation, say for example the linked list is at 1, 2 and 4. Linked list is at 1, 2 and 4. Now you are trying to insert 3. So it won't go into this scenario because you are trying to insert in the middle. And so you basically traverse until the previous dot next dot's value is less than head dot value. So you start off with 3 and previous dot next dot value is basically like you go until it is equals to 4 basically. So that's when it is less. So that's how you know you have to insert before 4. And so you loop until you find the specific spot for 3 between 2 and 4, and then you break out of this loop. And at the end you return dummy.next, which will be pointing to 1. So you return 1, and then whoever is using this can traverse from 1, 2, 3, 4, which is a sorted list. That's it. Thanks for watching. Let me know if you have any comments. Otherwise, I will see you in the next video.